Before we jump and talk about Kubernetes architecture and what it is, let me take you back to one repository here. So this EKS microservices deployment is the repository that has everything that I'm going to cover as part of this demo. So if you want to learn more about Dockers, you can check this document. And if you want to learn more about Kubernetes, so there is a document for Kubernetes as well. And let's go to here and let's see one microservices application. So this is one of the microservices application that is given by Google Cloud Platform. So let's go down here and see the architecture. Okay, so whenever the user makes a HTTP call to the front-end application, the front-end application is basically going to talk to all these back-end services depending on the application functionality. Okay, so all these rectangular shapes represent a service or a microservice, and typically they are supposed to have their own database, but in this case we don't have it, so let's ignore that part. Okay, so these are all these independent microservices. Now, so where does Kubernetes comes into picture? That's what I'm trying to talk about. Okay, so now we know Docker. We can Dockerize each of these microservices, right? We can create a Docker image and then we can push that image to Docker Hub, for example. But let's say this ad service is having maximum number of traffic. Let's say the request coming to ad service is too much. So in that case, this service might crash. So we want to make sure that we have multiple instances of these ad services are running in the production environment. Also, let's say we make like 3 instances of ad services running in the production environment every time. So that is called scaling up. So so another scenario might be, let's say we have a recommendation service that has 5 instances currently running, and then the requests coming to recommendation services are gradually decreasing. So in that case, we want to decrease the number of instances running in the cloud, because we don't want to consume a lot of resources whenever it's not necessary. So that is the idea. So how do we scale these things up? How do we scale these services down? How do we automate this process? What is the tool that is going to help us in this process? So so that's where Kubernetes comes into picture. And also Kubernetes helps us manage and maintain all these services when it comes to deployment. Okay, so let's talk about Kubernetes architecture now. Okay, so I'm going to put this on slide. So okay, so we're going to cover a few of these things here that is necessary as part of this demo. So let's see here. So what is Kubernetes? It's an open source platform designed to automate deploying, scaling, so that's what I just talked about, and then operating containerized applications. So it provides a framework to run distributed systems resiliently, handling scaling, failover, and deployment patterns for applications. So one of the major features of Kubernetes is it helps you in deploying multiple applications or containerized applications. Also, it supports scalability and self-healing. So scalability is something we just talked about. So automatically scaling up or scaling down the services based on demand. Okay, so we're going to cover how this works later in the demo part. So another important feature of Kubernetes is self-healing. So in case of some services crashing, we can automatically spin up another service. Okay, so that is self-healing. So these are the major features provided by Kubernetes. Now let's go here and talk a little bit about Kubernetes architecture. So Kubernetes architecture basically consists of 2 different sections here. You see the Kubernetes master and then the Kubernetes worker nodes. Okay, so the master component and the node components. So node components can be more than one, but then the master component is just one. Okay, so when we talk about this Kubernetes master, this is also known as the control plane. So basically this is going to make global decisions about the cluster. Now when we say cluster, a cluster is a combination of a master component and the worker components. Okay, so for example, this master component is basically responsible for detecting and responding to cluster events. For example, when to start a new pod, um, you know, things like that. So before that, let's cover about what is a pod first, right? So let's talk a little bit about this. Let's start with the master node first, okay? Or we can start with the worker node. Okay, let's go with the worker node. So if we go to worker node, so we have something called, so this is a worker node. So when you say node, it basically means a virtual machine, right? So we have something called kubelet here. So kubelet is basically the agent that runs on each of these worker nodes. So if you see here on worker node 1 there is kubelet, and also worker node 2 there is kubelet. So if we have 5 worker nodes, there's going to be one kubelet agent running in each of these worker nodes. Okay, so basically the idea is kubelet is going to communicate with the master node. Okay, um, and then it manages the state of the nodes, ensuring these pods are running, and these pods are healthy. Okay, now another component you see here is a Docker component. So this is a container runtime. So this can be replaced by any other container runtime. So one of the most popular container runtime is Docker. So we're using Docker here. Okay, so another one is kubeproxy. So kubeproxy is basically a network proxy that handles routing and load balancing of the services within the cluster. So we're going to cover what service is later on. Basically it maintains the network rules and enables service discovery. Okay, so we don't have any services as of now in this image, but we're going to cover what services are later on. Okay, now another important thing is we have something called pods here. Okay, so pod are the basic unit of deployment in Kubernetes, and then they encapsulate one or more containers. So if you see here, usually a pod has one container, but it can have one or more containers. So there are 3 pods, and pod 1 has 2 containers running, while pod 2 has 3 containers, and pod 3 has 1 container in worker node 2. Okay, while the case is slightly different in worker node 1. Okay, so that is basically the worker node architecture. Now let's talk about the master node architecture. So inside master node we have something called API server. So this is basically the central control point for all the interactions within the cluster, and this exposes the Kubernetes API and handles requests coming from the user. So usually the user will use some commands like kubectl, it's a CLI. So the requests that are coming from the user are going to be communicated through API server. Okay, and there's something called a scheduler. So a scheduler is basically responsible for assigning the pods to individual worker nodes based on the resource requirements and other policies defined in the manifest files. So we're going to cover what manifest files are later on. Okay, then we have controller manager. Controller manager is basically responsible for running various controllers that monitor the cluster state, and then it drives towards the desired state. So example, the replication controller, let's say how many replicas of a pod we want to make sure that are running on the cluster, the node controllers or the service controllers, things like that. Then we have something called etcd. So this is a distributed key value store used by Kubernetes to store the cluster state and configuration data. So they're going to store all the metadata about the cluster in this key value storage database system. Okay, so that is the basic Kubernetes architecture. We're going to cover a little more going further. So so I just explained all this Kubernetes plane and then worker nodes. So and also cover pod. So this is pod is like smallest deployable unit, and that's what contains the containers. Okay, so it can have one or more containers, single or multi-container. Okay, and one important thing to notice here is these pods are ephemeral, meaning that these pods are designed to be disposable and new instances replace unhealthy ones automatically. Okay, let's go back to this image here. So whenever a pod is created, an IP is assigned to this pod, and then whenever things go wrong, this pod can die, right? So when pod dies, it's automatically going to create another pod, okay? And a new IP is going to be assigned to this pod, okay? So that is the basic idea. Now, so there are different services types because since these pods are ephemeral, so there is no way we can access these pods with their IP because this IPs keeps changing, right? Once the pod dies, a new pod is going to come up with a different IP. So there's no way we can keep track of all these pods dying and coming up, right? So in that case, we're going to make use of another Kubernetes component called service. So there are three different types of Kubernetes services: the cluster IP, and this is the default type of service, basically making the service accessible only within the cluster. So basically when you create a service type of cluster IP, you cannot access it directly from the internet. Okay, now another one is node port. So node port basically exposes the service on the node's IP. Okay, and there is another one, load balancer. So this basically exposes the service externally using a cloud provider's load balancer. So whenever we create a service with the type load balancer, it's going to connect to the cloud provided load balancer, and then we can make requests to the load balancer API, which is going to communicate to the container. Okay, that is it. Now, okay, this is a Kubernetes cluster basically. So if we see here a deployment, okay, so deployment is another component in Kubernetes. So this basically is a abstraction over pods and replica set. Okay, so a pod and a container. So there is a pod and a container, right? And so what we can do is we can expose these pods with the help of service. And then there is one more component called ingress, which we are not going to cover as part of this demo, but this is like a routing configuration. So whenever a request comes to this ingress, how do you route your traffic? How do you make sure your request goes to a particular pod or a container? So this is where you can configure all these things. Okay, so there are other important Kubernetes components. So you can go back and check this document I put in this repository if you want to learn more about what all these components are. Okay, now there is one more component called namespace. Basically it's a logical separation between the Kubernetes resources. Okay, so we can define namespace, and then we can define what are the resources that fall under particular namespace. Okay, and there is one, if you don't specify any namespace, this resources is going to have a namespace called default. Okay, that is the default is the default namespace. All right, so the same thing. Okay, we are actually having the same information repeated here. All right, so this is the Kubernetes architecture. Now, okay, let's talk about EKS. Now, this EKS is basically a Kubernetes service managed by AWS. Now, this is where we're going to be deploying our microservices to. Okay, so in case of EKS, we don't have to worry much about this control plane. So this is fully managed by EKS, but then we create worker nodes. Okay, this EC2 instances we're going to create, and then we can deploy our microservices into these clusters. Okay, so that is the basic idea of EKS. Now you can go through these slides or read more about what EKS online. Now let's go down here, see more slides. Okay, now let's talk about deployment workflow for microservices. Okay, for this demo. So let me take you back to this repository here. Okay, so this is the repository we're going to make use of. okay? And we are going to deploy all these microservices, and then we're going to have one front end that is going to expose a service of type load balancer. So that's going to connect to the cloud service load balancer, and then we can, if we make a request to that IP address, we can actually talk to these microservices. So that is the plan. Okay, now, so for that we need a few things. Okay, so let's go back here and understand the deployment workflow for microservices first of all. Okay, so we have all these microservices here. So these are all the microservices here. Let's say we have 10 microservices, and then these microservices are already Dockerized, and then the images are pushed in GCP container registry. Okay, so we have everything ready up to here. Now what we need to do is we need to create a EKS cluster. So we're going to sign up to AWS, create an EKS cluster with probably 3 or 4 nodes, and then we're going to write our Kubernetes deployment files and then apply that to create the Kubernetes resources. Okay, so that is the main idea. So now let's see what we have down here. Okay, so in order to create a cluster, so there are a few things. Okay, so for that, let's go back here and go to the same repository I talked about before. Okay, so there is a few setup required in order to create a cluster. So before we're able to create a cluster, we need to do a few setup. So I'm going to walk you through this setup first of all, and then we can start creating cluster.